CS 3D Imaging Introduction to CS 3D Imaging Recorded Class. This recorded class is designed for all team members and provides an introduction to the CS 3D imaging software. By the end of this class, you should be able to navigate the software, utilize tools in the view windows, explore the numbers on the MPR views, and manage adjustments.
Navigating the software. After launching the patient's volume from your imaging management program, you will notice the title bar along the top of the software where you will find the product name on the left side, the name of the current patient in the center, and the standard Windows controls on the right side. Just below the title bar, you will find tabs which include workspaces for orthogonal slicing, curved slicing, custom slicing, oblique slicing, and review tabs. To the right of the tabs are the utilities, which include ability to update new implant library when your computer is connected to the internet, patient information, software information, preferences, and access to online help. Tool panel include a set of tools that change according to the tab you have selected and your software configuration. Some tools provide additional information in secondary panel when drop-down arrows are selected. CS 3D Imaging provides the following standard views of 3D volumes, shown here in the orthogonal slicing tab. The 3D view displays a complete three-dimensional perspective. Here, the plane tools is activated with respective colors to each of the MPR views. MPR refers to multi-planar reformatting views. The default colors of the MPR views are as follows. The gold-colored triangle represents the axial plane. This plane cuts through the anatomy parallel to the floor, separating the superior from the inferior. The axial plane view can be adjusted by moving the gold control points in either of the other MPR views. The purple-colored triangle represents the coronal plane. This plane displays a cut through the anatomy from ear to ear and separates the anterior from the posterior. The coronal plane view can be adjusted by moving the purple control points in either of the MPR views. The green-colored triangle represents the sagittal plane. This plane displays a cut through the anatomy from medial to lateral, separating the left from the right. The sagittal plane view can be adjusted by moving the green control points in either of the other MPR views. Utilizing tools in view windows. We'll start with the 3D Scene window tools and look at them one by one. View Snapshot button copies a 3D scene to the gallery for printing. The snapshot rendered in the gallery will be the DICOM format. Maximize, Minimize buttons maximizes or minimizes the 3D scene. Dual Screen button opens the current view inside a new window. You can drag the new window to another monitor. Sagittal orientation changes the 3D scene to a sagittal orientation. Coronal orientation changes the 3D scene to a coronal orientation. Axial orientation changes the 3D scene to an axial orientation. Perspective orientation rotates the 3D scene to give perspective from all slices from this view. Orientation indicator shows which view of the scene that you are looking at. Each letter represents a view. H is the view from above, represents head. F represents foot, view from below. L and R is left and right view. A and P is anterior or posterior view. Now let's focus on the window tools available in the other views known as MPR view. Note that all MPR views have the same set of tools, and these first three were also available in the 3D view window. View snapshot button. Here we'll copy an MPR view from which the snapshot was taken, send it to the gallery for printing. Just like the 3D scene snapshot, the MPR view, the snapshot rendering, will be of a DICOM format in the gallery. Maximize, minimize buttons, like we saw in the 3D view window. This tool will maximize or minimize the MPR window. Dual screen opens the current view inside a new window. You can drag the new window to another monitor. Split view. Click to change the view from 1 to 1 like we see here to 3 by 3. Other selections that are available: 5 by 5, 1 by 3, 3 by 1, 1 by 5, or 5 by 1. Once the split view selection has been determined, the tool allows selection for slice spacing. The choices are as small as 76 micrometers up to 2.3 millimeters for this view. This tool is inactive when split view is just set to 1 to 1. Set integration mode toggles between averaging and maximum intensity projection (MIP) modes. It's active only in 1 to 1 view and requires integration thicker than 300 micrometers. This is useful for a clearer visualization of certain anatomical points of interest. Here's an example of the MIP, or maximum intensity projection mode. Set integration button, active only for 1 to 1 view, will increase or decrease the slice thickness. Choices here are as thin as 76 micrometers upwards to 53.2 millimeters in this view. Our next objective: exploring the numbers of the MPR views. Each of the cut plane MPR views in the 3D module has a millimeter measurement and a zoom measurement. When you hold your mouse over regions of interest in the MPR view, the relative density numbers are also displayed. Let's take a look at each of these numbers. Here is an example of a millimeter measurement. This measurement enables coordination between the multiple practitioners when viewing the same volume on different computers. The position within the 3D volume is represented by a millimeter number in the upper left corner of each MPR view. In this example, the axial slice displayed 23.79 millimeters indicates the distance from the bottom of the volume to the selected location. The larger the number, the closer the slice is to the top of the patient's head. This can be adjusted by using the matching colored control points in either of the other MPR views as shown earlier. In this example, the coronal slice, 14.38 millimeter, indicates the distance from the most posterior point of the volume to the selected location. The larger the number, the closer the slice is to the patient's posterior regions. In the sagittal slice displayed in this example, 32.05 indicates the distance from one edge of the volume to the selected location. The zoom number in the lower left of the MPR view indicates how closely the representation of the image is to the actual size of the anatomy. It does not affect measurements made on the original 1-to-1 image slices. To adjust the zoom, use the mouse wheel to enlarge or shrink the cut planes. Note, adjustment settings for mouse needs to be set to zoom. Simply place the cursor over the cut plane and roll the mouse wheel to the appropriate zoom. The relative density number, displayed in the lower right corner, when the mouse is held over a portion of the MPR view, can be used to compare density within a volume. The higher the number indicates the higher the density. In this example, the mouse was held over the apex of the tooth. In this example, the mouse was held over the restoration. Managing adjustments. The CS3D imaging provides two libraries of presets for quick access to viewing parameters that can be reused in different situations. The windowing preset library provides access to presets for brightness and contrast profiles, whereas the color palette library provides access to color palettes, and that can be applied to the 3D scene for viewing specific features. Each of the libraries provides a set of standard presets. In addition, you can add or edit your own presets libraries. Let's take a look. MPR adjustment windowing presets. In the CS3D imaging, a provided preset of brightness and contrast profiles. These can be selected from the drop-down menu next to the currently selected preset. You can change the values of the brightness and contrast by utilizing the sliders. You can set the manager dialog to save the current presets or reset using the rotated arrow at the bottom of the adjustment window. Using the windowing preset library to select the presets of brightness contrast appear in the drop-down list and where you can choose the default preset. You can also create new presets that you can add to the library by selecting Save Current Windowing Presets and complete the necessary dialog. CS3D imaging provides preset color palettes. The color palettes are available for volumes acquired on the 9000 series. They are Bone, Transparent Bone, Grayscale, and Realist. In addition, palettes for Guide are available on the images acquired with a 9500 or a 9300 acquisition machine. You can change the amount of 3D scene shown by each color preset utilizing the sliders next to the density indicators. There are 6. S represents skin or less dense areas. F is for flesh, such as soft tissue. Bone for bone tissue. The D is for dentin, calcified tissue. E, enamel, for tooth enamel, and A for amalgam, such as restorations. For the S indicator, the settings should be set low so that the skin, hair, and other minimal dense areas are not displayed. If changes are made to the active palette, the drop-down list displays an asterisk to the right of the palette name. You can remove these changes by clicking the Reset option at the bottom of the window. The palette library is where you select a palette appear in the drop-down list and where you can choose the default palette. The color palette window lets you create custom palettes that you can add to the palette library. Select or deselect the palette as your favorite. By the way, favorites are displayed in the drop-down list. Here you can also designate a palette as the default palette or change the color settings of a palette.
Now you should be able to navigate the software, utilize tools in the view windows, explore the numbers on the MPR views, and manage adjustments.